Hello class, today we're going to do relations and functions. If you'll look at one of your Frere models, what I would like for you to do on one of them is to, in the center where it says vocabulary word, write relation like you see on your screen. I already have mine done up and I'm going to show you each section, so you don't have to pause the video right now because I'm going to go through each section individually. So let's go to the left top corner where it says My Definition. And let's talk about what a relation is. A relation is a set of ordered pairs. Any ordered pair is considered a relation. So you have your input and your output. Your input are your x values and your output is your y values. So make sure you write this in the box for My Definition. Now let's move over to the top right to characteristics. There are multiple ways to represent a relation. We can represent a relation by writing ordered pairs. We can do an input-output table, or you may know this as an XY table. We can also plot the points on a coordinate plane, so we can graph it. Or we could do a mapping diagram, which I'm going to show you those. Or we could have an equation, or it could be written in words. So underneath example in the bottom left, if you were given this set of ordered pairs, you have 4, 7, 3, 2, 0, 0, -1, and -4. That would be considered a relation because you have sets of ordered pairs. Then there's also the input-output or XY table where you have your points listed. If they asked you, is this a relation, you would say yes because it represents ordered pairs. Now they want some non-examples, some things that are not relations. So some things that are not relations. The number 4, that's a constant. It is not a relation because it is not part of an ordered pair. If you have just the variable x by itself, this would not be considered a relation because, again, a relation is a set of ordered pairs. And then you have 7x, which again would not be a relation because it's not ordered pairs. That would be considered an expression. Now let's look at your second Frere model, and in the center of this one we're going to write function. So if you'd write that in the center for me, please, and then we're going to do the same way with this one that we did with relations. So my definition for a function is a relation where every input has exactly one output. In other words, there are no repeating x values. So a function is a relation, which means ordered pairs, where when you have a whole set of ordered pairs, there is only one output for every input. Now look at characteristics. One of the characteristics about functions is that if you can draw a vertical line through the graph of a function, or a graph, it doesn't have to necessarily be a function, that touches it more than once, it is not a function. And so when it touches the graph that's graphed more than once, we say that the relation fails the vertical line test. If it passes the vertical line test, then a graph is a function. And again, I'll show you that here in just a second. So here we have 3 different representations of relations. And in order for them to be a function, there has to be no repeating x values. If we look at the set of ordered pairs, and we look at the x values in each set, okay, do we have any x value that repeats? No, we do not. Every x value is a different number. Therefore, this is a function. If we look at the graph, when I draw a vertical line down the graph, the line that we drew that was graphed, in other words, this line right here, this is the line that was graphed. When I drew a vertical line across it, it only crossed one point on that line that was graphed. If I draw a vertical line again, it only crosses one point on that vertical line. Draw another one, it only crosses one point on that line. Therefore, it passes the vertical line test. If it passes the vertical line test, it is a function. You have to be able to draw a vertical line anywhere on the coordinate plane, and it only passed through the graph one time. Now let's look at the input-output table, or XY table. Remember I said that a function has no repeating x values. So if we look here at our x values, we have 1, 2, 3, and 4. Are any of those numbers repeating? No, they are not. Therefore, this would be a function. So if you are ever given a set of ordered pairs, you look to make sure there are no repeating x values. If there are no repeating x values, it's a function. Same way with an input-output table. Look at your x values. Then when you go to a graph, see if it passes the vertical line test. Now they want us to do some non-examples. So here are two non-examples. This one that you're looking at that you're probably sitting there going, what is that, where it says input X, output Y? This right here is called a mapping diagram, and you will see these. It's just another way to write ordered pairs. So if I were to write the ordered pairs represented in this mapping diagram, I would write that one of the ordered pairs is 3, -5. I would write that another ordered pair is 3, -2. Another ordered pair is 4, 1. And another ordered pair is 4, 5. Do you see how I got those? I matched one X with the Y that the arrow went to. So now when I look at this, I look at my X values. Do any of my X values repeat? Yes, they do. There are 2 3s and 2 4s. Therefore, this is not a function. Now we have a graph over here. When we have a graph, remember what we do. We do the vertical line test. If I draw a vertical line through this graph, do I cross what is drawn on the graph more than once? Yes, I do. I cross that graph here, and I cross that graph right here. Therefore, this is not a function. Tomorrow we are going to practice determining whether different representations are functions, and we're also going to learn the different representations in more detail about, ordered pairs, graphs, mapping diagrams, and input-output tables. So, we will see you tomorrow.